never gonna hear the end of it. There's not going to be that many that are integration by parts, right? The vast majority, half or more, are going to be integrate.
That's why we're confused.
Most of them are going to be use substitution, okay? Few integration by parts, probably no more than two, and then basic antiderivatives, and we're going to practice some of all that here later today. But so integration by parts. So how do you recognize if it's going to be integration by parts? Because it never fails. It seems like every year I've got somebody who on like every problem is putting U and dV and V and du and like on every one. It's not going to be that way. Okay, there's not going to be very many of those. Matter of fact, they're pretty much going to look like this. Okay, what's that? And you can't. No, it's not like it's not like you have a choice. You know, hey, here's an antiderivative. I like this method. I'll do that. That's not the way it is, right? There are certain methods that work for some and certain methods that work for others. Very rarely is there a situation where you can pick one or the other. Now, the ones I want to look at a couple at the end of the book homework today where you had to do a combination, like a use substitution and an integration by parts, or vice versa, okay? And that sometimes can happen. Now, gateway test, probably not going to do that. I'm going to focus on the different techniques, so I'll give you one that's an integration by part, give you one or some that are use substitution, whatever, and not mix the two together. But for practice and so forth, we still need to do that. We're not just doing the bare minimum. Here's what's on the test. That's all we're going to practice. We're going to, some of these are harder. We're harder than what you'll have to do on the gateway test. But that's okay. So they're going to look like this. Mixture of algebra with a trig, or an exponential with a trig, or an algebra with an exponential, or an algebra with a log, something like that. And the other thing is, very clearly, there is not stuff on the inside, so you wouldn't pick use substitution anyway. Right? Yesterday we talked about how if this was e to the x squared, you would do u substitution, because you could let u be the inside, the x squared, and the du would give you your x dx. That's why you would pick u substitution. So this is what they're going to look like. If they don't look like this on the gateway test, you're not doing integration by parts. If there's something on the bottom, right? If you got a fraction with stuff on top, stuff on bottom, you're doing u substitution. If there's stuff on the inside, you're probably doing u substitution. Now, when I say stuff on the inside, you might get something like this. That's still an integration by parts. Just because there's a 4x on the inside, that means you're going to kick out a 1/4, right? When you do the antiderivative. If you do the derivative, you'd be kicking out a 4. So to me, that doesn't count as stuff on the inside. I'm talking about if you got an x squared in there or something like that. Okay, if it's just a constant that's in there with it, that doesn't matter. That doesn't make it automatically a use substitution. Okay? So that's what to keep in mind. Matter of fact, I don't have a lot more practice ones for integration by parts. There is a website. Now, we pulled it up last block and my Flash or Java player wasn't updated or something, so it wouldn't run. So I don't know, on Chromebooks or on your home computer, whatever, you may not get that site to run or work very well. So basically, I've got some PDF with some review problems that I'm going to post. That has a few integration by parts on it. Okay, but again, you probably need more practice with the use substitution because there's more of those anyway. All right, so here's a couple I want to go through. So let's talk about number 20 here. Now, this is a simplified version of number 20 that I want to do today. Number 20, I think it was like e to the 3x, and it was cosine of 4x, right? Something like that. 2x, cosine 2x. Okay, and the reason I'm going to do this one over here, so if you want to jot it down with me, I'm going to do this version on the left, because the only difference between what I'm going to do and what number 20 actually was is you have to kick out a 3 or a 1/3 or kick out a 2 or a 1/2 when you go through it. And then you get all these fractions in there that kind of get in the way. Now, you need to be able to deal with those, but for right now, there's something more important I want to show you with a problem like this. Now, I'll say it right up front, I'm not going to make you do one of these on the gateway test, okay? But I want to show you today, spend just a little time, now that we've done some integration by parts problems, I want to show you some of the issues, some of the things that can happen when you do an integration by parts. All right, so on this one, we got an exponential and a trig. Liate would tell us to let what be the u? The trig, right? Trig comes before exponential on Liate. So the dv would be the e to the x dx, right? And so the du would be cosine x dx, and the v would be e to the x, right? And so now we follow our formula, and that would be u times v, so that'd be e to the x sine x, minus the integral of v, which is e to the x, and du, which is cosine x dx. Now, by the way, I want to repeat this. I said this yesterday, and I still had some people messing it up. If there would have been like a 4 outside of here on this cosine, say we had sine of, like on this one, we got the 2 in there, and so you'd kick out a 2 right here, you do not divide that over. Did I mention this yesterday? You do not divide that over like we do with u substitution, right? Because your formula is uv minus v times du. You want to substitute du. Well, du is cosine x dx, or if there was a 2 here, that would be 2 cosine x dx. You want the 2 to go into here. You do not divide that over when you're doing integration by parts. All right. So anyway, now, remember the whole point of u substitution and the whole point of integration by parts is what? Trade our original integral for a new one, hopefully an easier one, hopefully one that we can do. Now, the best thing that would happen is we trade our integral for a new easy integral that we can just do a basic antiderivative on. That's what we hope for, and on the gateway test, that's pretty much what's going to happen. You do an integration by parts, it's going to be, your new integral is going to be an easy one that you can do. But it wouldn't have to be. It might be a new integral that you could use u substitution on. We're going to do one here in a minute. It's number 20, actually. Or no, number 19. Number 19, that happens. So you might get a new integral that you can do another technique on. All right? Same thing with u substitution. You might do a u substitution and end up getting a new integral that you have to do integration by parts on. That can happen. Now, that's not going to happen to you on the gateway test. They're going to be, you do u substitution, get your answer. Do integration by parts, get your answer. Or it's just going to be a basic antiderivative. All right? So anyway, you look at this, and what do you notice with this one?
Same.
It's the same thing, basically. So we need to do what?
Something.
Well, we have to do integration by parts again. I mean, there's nothing else to do. We can't do u substitution. We can't do each individual antiderivative. If we could, we would have done that in the beginning, right? Basically, it's integration by parts again. Now, I've already used u and v, but I won't get it mixed up because I'm done with those. I'm down to this now. So I'm going to do it again. Okay? So now, exponential and trig. So trig comes before exponential, so I'm going to let u be the cosine x, and the dv is going to be the e to the x dx. And let's see where this leads me. So the du would be negative sine x dx, and I do not divide that negative over, right? I'm going to leave that there. And the dv, so the v would be the antiderivative, which again is just e to the x. So now I write this down. I'm going to leave this over here, so I got to line this up because I'm only working with this integral here right now. So I got u times v, so that'd be e to the x cosine x, minus the integral of v du. Now, there's a negative there, so that's going to turn that to a plus. And now that's going to be e to the x sine x dx. What do you notice? It's the same thing. It's just going to keep going because my e to the x keeps being e to the x when I do the antiderivative, and the sine derivative keeps flipping from cosine to sine to cosine to sine, except with a negative in there. So if I keep going, it's just going to keep going forever. But there's a nifty little trick here that I actually don't need to keep going. Okay, so let me write what I've got so far. I've got e to the x sine x minus, and then all this, right? So I distribute that negative. All right, now what do I really have? What I really have now is that this, right, is equal to this, right? Would you agree with that? Okay, this is equal to this. So let's write that. Let me go to a new page here. And so this is what I have. The integral of e to the x sine x dx is equal to e to the x, I forgot what it was, e to the x sine x minus, now I got to distribute that negative, so minus e to the x cosine x, and then distribute that negative, minus the integral of e to the x sine x dx, right? Isn't that what I have? Let me see anything. I mean, I got that there and I got that there. Trying to figure out what this is. I'm going to do it like I would do to my algebra class. Call that the red thing. Now that's also the red thing, right? And it's like an equation. In my algebra class, I call these wall problems. I put a wall right here. Red thing equals something something minus the red thing. What could I do here to both sides? Hint, hint. How about if I add the red thing over to this side? What would I have? 2 red things. I'd have 2 e to the x sine x dx is equal to e to the x sine x minus e to the x cosine x. And what am I trying to find? What was I trying to find here? What this equals. That's what I was trying to find. Now, what does this equal? Just divide both sides by 2. There it is. I found it. Pretty slick, right? Because what happened was I was getting my original integral equal to something something minus my original integral, so just add that over to that side. I got 2 of those, divide by 2, and there it is. Okay, again, I'm not going to give you that, but that's going to happen anytime you have an exponential and a sine cosine together because of what you said. It just keeps repeating. Well, after 2 times through, you get back to what you started with, and so it's a neat little trick that works. Okay, now another thing where you might have to, I don't know if this happened on your homework, but when we did this one, right here, we had x e to the x dx. This is the one we did yesterday. And we had u equals x. Let me do it real quick. We had dv equals e to the x dx. So our v was e to the x. And our du, the key was right here. The du just came out to be dx. Well, then when we did our uv minus our integral of v du, we just got this, and then that's an easy integral to do, and we were done. However, what if this would have been x squared here? No. U substitution wouldn't work. If there'd have been an x squared up here, yeah. But here, it wouldn't have. So, yeah, the u would have been x squared. This would have been 2x dx. And so then when I did so this would have been x squared. And then when I did the integral of v du, I'd have had 2. And then how would I do this integral? I have to do integration by parts. But it's not going to keep repeating because my original had x squared. This one has x to the first. What will the next one be? Just e to the x, and then I'll be done. So I have to do it twice, and then I'll be done. Now, if this would have been x to the 7th, I'd had to do it like 7 times, right? Because I had x to the 7th, then I'd had x to the 6th, and then I had x to the 5th, and then x to the 4th, and I would never do that to you. But I'm not even going to make you do it twice, okay? But sometimes with your algebra here like this, that's what could happen, right? So that's another thing with integration by parts that sometimes you run into. Okay, but we're not going to mess with that. We'll keep it a little simpler than that. All right, so that was that one. Let's go on to 19. 19 shows another situation that can happen with integration by parts, and that is we do the integration by parts, and then we get a new integral that needs u substitution. Now, the reason I want to do this one, even though I'm not going to make you do this on the gateway test, is I might give you the integral we're going to end up with here as just a u substitution problem. So it's worth going through just for that. And then this is a really nasty one because then you got to plug these numbers in at the end. And I'm not going to, you will have to do, of the 10 questions, you'll probably have 1 or 2 that'll be definite integrals. Most of them will be just do the antiderivative plus c and be done. But there will be 1 or 2 where you have to plug in, do f of b minus f of a. Okay? All right, so this one we got an inverse trig and an algebra. Which one comes first for my u? Which one? Liate? Inverse trig. I is before the A, right? Inverse trig. So it should be arctangent is what we want to pick for the U. Well, we have to because we can't do the antiderivative of arctangent. We don't have a rule for that. So it's got to be this right here. We know the derivative of arctangent. We don't know the antiderivative of arctangent. Okay, so U would be arctangent. The du would be 1 over 1 plus x squared dx. What's the antiderivative of x squared? 1/3 x cubed, like so. Okay? All right. Now, we put it together with our formula. So we got u times v, so that would be 1/3 x cubed arctan x minus the integral. Now let's think about this. The integral of v du. All right, so 1/3 I can just put in front. And when I times x cubed times this fraction, how should I write? No? Yeah, we can't split up the bottom. You're thinking of it backwards there. It would just be x cubed on top of 1 plus x squared, and then a dx out at the end. Okay, that would be the way to write. Now, our hope when we do an integration by parts is that we get a new integral that's an easy one to do. We just, boom, just do a quick antiderivative on it. And on the gateway test, most of the time that's what will happen. However, this one isn't. But this is worth doing because I might give you this right here as a problem on the gateway test, right? I might give you this one. All right, so let's look at that. Let's just look at the black box now and think about doing that problem. It's not an integration by parts. It doesn't look anything like these ones we said over here that integration by parts would look like, right? Doesn't look anything like those, so it's definitely not an integration by parts. It's a fraction. It's definitely not something from page 333. So what are your choices? It's got to be U substitution. What are your choices for U here? I think the bottom. Now, somebody in the other class said x cubed, and I know what they were thinking. They were thinking, well, if u is x cubed, the du would be 3x squared dx. And there's an x squared here, but is that an x squared dx? That's not an x squared dx. It's a 1 over. And it's not even 1 over x squared. It's 1 over 1 plus x squared, which is a whole other thing. So letting u be the top is usually not a very good thing anyway. Okay? Letting u be the inside or letting u be the bottom is where you want to go. Now, the problem with that, letting u be 1 plus x squared, what's the du? 2x dx. I don't care about the 2, we'll deal with that. But x dx, is there an x dx setting here? There is. Because x cubed is the same as x squared times x, and then times dx. So we can, I hate to call it splitting it, because that's what we do when we're adding or subtracting, but we can make x cubed be x squared and x, and then the dx, and we can parse that out, and we can take the x and the dx and put those together. We've never had one like that, but that's why we're practicing these. Every time we do some more of these, we run into some little tricks and little things we can do. So I'm going to make this x cubed be x squared times x, and then that's going to be a good thing to do. So I'm going to let u equal 1 plus x squared. The du will be 2x dx. Now I'm doing u substitution here, so this is one where I'd want to move that 1/2 over there, okay, because I'm trying to sub these things out here and get a new integral. So right here, that's 1/2 du, right? That's x dx right there. So that's the same as 1/2 and du. The bottom is, well, it's going to, I'm doing the black box. The 1/3 is going to come in. I'll just bring that in later. Yeah. And that is one of the tough things about these integrations by parts. When you have this stuff here, you got to remember to bring it back in there later. Okay, so the bottom is u. And what's left? I still haven't subbed out this x squared. X squared is u minus 1. I get that from right there. X squared is the same as u minus 1. So that x squared can go on top. That can go as u minus 1. And we've seen that before, right? We split that apart. So I've got my 1/2. And then that's going to be 1 minus 1 over u. And when I do my antiderivative, I'll have 1/2 u minus 1/2 ln u. Right? Now, I got a lot of stuff here, and then I'm going to put my 1 plus x squared back in for that u. I know I got another u up here, but I was done with that. So this u is 1 plus x squared. So all told, when I'm done, and I'm not technically done because I haven't done the definite integral, but we're not going to spend time on that. So I've got 1/3 x cubed arctan x minus, now I got to distribute this minus 1/3 to those pieces. And while I'm at it, I'll put my 1 plus x squared back in. So 1/3 times 1/2 would be 1/6. And for u, I'll put 1 plus x squared. And then minus 1/3 times minus 1/2, that would be plus 1/6 ln 1 plus x squared. And 1 plus x squared is never negative, so I don't really need the bars. But if you put them, that's fine. And then plus c. Wow. And if we were going to do the definite integral, we would put the right bracket, take off the plus c, and we plug those numbers in. What a mess. But the black stuff, well, up until the very end here, that's kind of a new u substitution, another little twist on a u substitution that we might sometimes do. Okay? All right. Let's look at number 31. Okay, number 31. Now, I kind of misinterpreted, I think. I didn't look in the answer book to see what they did. Let me read that again, because somebody in the other class did something that I didn't think about doing, and it actually worked. It says, use the substitution u equals x squared and integration by parts to find this integral. Well, that's how I normally have done that one. Somebody in the other class went straight to integration by parts. They used the u equals x squared and then did, okay, and I didn't think of that, but but then they did it. Now they actually did it wrong, but it made me think. Well, wait a minute, that might work. Yeah, no, on this one they did it in the answer book. They do it like what Kelsey was saying. That we do a u substitution and then we do an integration by parts. So a minute ago, on problem 20, we did integration by part, or no, on the one we just did, we did integration by parts, and then the integral we got needed a u substitution. Well, this one we can do a u substitution, and then we'll need an integration by parts. But then, Allie, I want to talk about what you did. So here's the way I interpreted what they wanted us to do. They wanted us to do u equals x squared, and so du would be 2x dx like this. Now, when we sub that, this part would be e to the u. The 2 I'm going to move over here. Now, is there an x dx here? There actually is. We just learned that in the last problem. The x cubed, we can do that to it. So the x and the dx becomes a 1/2 and a du. And then this x squared is u, and so we can put a u there. Now, what do we need to do that? We need an integration by parts. This is one we did earlier, x times e to the x, right? It's u times e to the u. So we could go through now and we could do an integration by parts with it. Problem is, I've already used u, so we were doing it this morning. We just went and changed all these to w's. We just changed all these to w's here, and then that made it. Right? Now we could do an integration by parts with our u and our v. I'm not going to finish that, but because we've already done that problem. But, so you would go from there. Now, and Allie, I don't know if this is what you did, but this is what I realized we could have done is, and I don't think this is what they intended, and there is kind of an issue with it. See what you guys think. If I do this, if I let u equal x squared, what would dv be? Well, no, it's got to be everything that's left. So if I've already used x squared for the u, there's an x left with the rest of it. So I get x e to the x squared. Yeah, I wouldn't want to put a u there because that'd be mixing stuff up. So the x squared I used here, and everything else has to be the dv. So the x that's left plus that has to all go there. Now, this part's easy. The du would equal 2x dx. I have to do the antiderivative of that. Well, actually, I mean, when I say I have to do the antiderivative, basically I have to do this, right? Well, isn't that a pretty easy one? Isn't that a u substitution? You'd let u be the x squared. The du would be 2x dx. There's an x dx setting right there. Now, normally we don't want to have to do that inside of an integration by parts, so we don't want to have to go through that whole mess of it. But it actually isn't bad. It actually ends up being just 1/2 e to the x squared. And if you've done enough of these, you know, that actually isn't that bad. But the point we're at, I'm not sure thinking about that and so forth would be easy to do. Then when you do your u times v, so you get 1/2 x squared e to the x squared minus the integral of v du. So if you multiply these two together, the 1/2 and the 2 cancel, and you just end up with x e to the x squared dx, which is the same thing we just had here, right? This would be a u substitution. You let u be that, you know, and so this ends up actually being 1/2 e to the x squared, you know, plus c. So the whole thing. And so if you work that out this way, the way we're talking about doing the integration by parts, you'll end up with the same place. But don't worry about that one for the gateway, with all those different moving parts. All right. So I wanted to get into that. I wanted to spend a little time today talking about integration by parts, some of the more difficult things, some of the strange things that can happen. And while we were doing it, we did get a focus on, we did get to see some little tricks that you sometimes might have to do with a u substitution or something like that. We talked about splitting apart, right, a little bit, something like that. You know, so we've gotten into some of those things. But now let's turn our focus to kind of, all right, that's everything we've learned now, what we've seen about being able to do these different antiderivatives. Now let's practice some for the gateway test, right? Do you have some questions on some that you tried in the packet or in the book or whatever that you want to take a look at all? In the book? Now, is that an integration by parts one again? Let me make a comment about that one. Okay, so you've got a trig and a algebra. So according to Liate, you'd let u be the x, right? And you'd let dv be the cosecant squared, right? This was in the book homework, number 18. Now, what's the antiderivative of cosecant squared? It's not one you have to memorize. Secant squared is. What's the antiderivative of secant squared? Tangent. The antiderivative of cosecant squared is negative cotangent. Negative cotangent. Okay? And then what happens is when you get into your integration by parts, you end up having to do the integral of cotangent. Well, you would do this the same way we did tangent yesterday. How would you write cotangent? You'd write cosine over sine, and you would let u be the bottom. You would let u be the bottom. And it would end, and then the du would be cosine x dx, which is right there, so it ends up being 1 over u, so it ends up being just ln sine x plus c. Okay? But don't worry about that cosecant squared, but we did talk yesterday about if you're doing tangent, and the same thing be true with cotangent. If you're doing the antiderivative of those, split them into sine over cosine or sine, let u be the bottom. That's how you handle those. Okay? All right, what else? Specifically the LH packet. Was there any there? Or the book, U substitution ones. I don't know if you went back and tried any of those, but that's a pretty good place to get some more U substitution practice. Well, okay, how about this then? Because some of you are at various different places. You've tried some, spent a lot of time with some, and you may be having as much. So let's get everybody up the same page here. Let's practice some. So what I've got here is I've got a PDF that I've put on the website. So if you go to our class website here and go to today's date, Thursday, February 19th, okay, we've got our assignment, which is what I have up on the board, which is just practice, practice, practice. And then right here I have antiderivative in-class review number 1. And it's a PDF document. It's got 11 problems on it, and then the answers worked out. So let's start by doing some of those together here. I'll let you work on them, and then we'll go over some of the answers. I'll post some of the answers. So if you want to, matter of fact, if you want to, we can divide up, or you can kind of work in groups if you'd like to, or you can just work individually. I don't know, it's kind of practice for the gateway, so maybe it's better to try them individually. But whatever, if you want to partner up or whatever, I'm okay with that too. But this is so here's 3. What I'll do is I'll leave these 3 up here. Why don't you jot down all 3 of them and leave yourself some space. Okay? And then here in a little bit later, I'll scroll up a few more. Then we'll take some time to go back and show you the answers. So we'll double check, make sure we're on the right page. Make sure you're kind of. That's x to the negative 6. Yeah, this is a 7 here at the beginning. This is x to the negative 6. What I've tried to do is split it up here a little bit, throw in some basic antiderivatives, throw in some U substitution, throw in some integration by parts. Okay, these would be, I think, the kinds of things we're talking about being on the gateway test. Okay, these would be the types of problems you could expect. Okay, so why don't you jot those down and then start working on them. Again, if you want to get together and work, I'm okay with that. But the idea is that you could, get to where you can do these by yourself like it was a gateway test. But at this point, we're still reviewing, and so if you want to talk it over, that's okay too. Then towards the end of the period, we'll get on the website and we'll look at some of those problems.